Hi everyone. Today I'll be talking about multi-dimensional gender bias classification. So this is a paper from EMLP 2020, and I think the authors are from Facebook.AI and some like French school or something. So, the motivation for this work is that NLP models that replicate unwanted gender biases present in society can affect downstream applications and lead to poor user experiences. So, for example, we can have a chatbot that insults the gender of feminists or something. So that will be distressing for them. Existing work on gender bias fails to recognize different dimensions along which use of language is affected by gender, and the existing work which excludes work which are not explicitly gendered based on a word list is problematic because oh my god, there can be strong anchor of gender stereotypes. Okay, so basically the contributions of the authors are that they propose a multi-dimensional framework for measuring and mitigating gender bias in language and NLP models. They have collected an evaluation data set, MDGender, for performing gender identification. They have trained a suite of classifiers to label gender in a multi and single task setup, and they illustrate the utility of the classifiers in downstream applications. So let's start with the framework that they propose. So they define gender as either masculine, feminine, neutral, or unknown. So they feel that binary gender is completely inadequate for the task. So they say that the neutral category refers to non-binary gender identity. Or identity with unspecified gender by definition. So, for instance, a talking tree character. So, unknown category for when the gender is not known. So, I think for the classifiers, they'll allow the classifier to put any label on an unknown category. So they decompose gender bias into 3 dimensions, and they give some sort of intuition about why they do so. So they have gender of the topic, so something that someone is speaking about. So the intuition is that we change how we speak about others depending on who they are. So perhaps you want to speak to someone who is your superior differently from someone who works for you. So I think that extends to gender as well. You talk to a man, talk about a man perhaps differently from how you talk about a woman. Gender of the addressee. So the intuition is that we adjust our speech based on who I'm speaking with. Oh my god. Okay, I'm sorry, I messed that up, but okay. So who you're speaking to is relevant to how you are speaking. And the gender of the speaker, who you're speaking as. So the gender of the speaker can affect what they say and how they say it. So let's say the same thing that is said might be said differently by a man and by a woman. Okay. Just to illustrate, so this phrase, when I first started dating him, my husband had a man bun just like yours. So with the I and the my husband, you kind of know that the person is speaking as a woman, and she's speaking to a man because there's a man bun just like yours, but she's speaking about her husband. So yeah. So for the classifiers, they propose the same architecture and pre-training as BERT-based. So Transformer provides representations for textual input and sets of classes. So I guess it's like masculine, feminine, and neutral. And the classes are scored by taking a dot product between the representations of textual input and given class. So I think the inputs are just sentences from their data sets. And so a single task classifier is trained to rank masculine, feminine, or neutral labels for each dimension. So let's say we have a sentence that says, "Hi John." So for the two dimension, we would classify this as to masculine. But a multitask classifier is trained to rank masculine, feminine, or neutral labels for possible dimensions given the textual input. So let's say, "Hi John, I'm Joan." So that would be expect the classifier to give a result like a two male from female, something like that. The data set, so they have collected training data from a variety of sources. And so for the about dimension, they have Wikipedia, image chat, Funpedia, and Visit. So I guess those are like encyclopedic entries. So Funpedia is just like a more fun version of Wikipedia. And so what they take is they take the biographical entries from Wikipedia. So biographies, of course, talk about individuals and describe them. So that would be the about dimension. And I think they do something like they count the number of he's and she's in the passage to kind of put a label on whether this biography is about a man or a woman or something else. And they have Yelp, so S. I guess for that, they rely on some prior work on labeling the male and female. And then, so this is S because the Yelp is about, I think, restaurant reviews and stuff like that. So, so they would be commenting as men or as women. And then Conf AI tool opens up and like, I think those are data sets that contain conversational data. So they would contain both S and two dimensions for the data. So you would, if you have people having conversations, then you have data about both speaking as someone and speaking to someone. And they have proposed an evaluation data set, MDGender, which will be talking about data. Well, here's the performance of their multitask model on the different data sets. So you can see that for Wikipedia, it's quite high actually, quite good at telling whether it's male or female. They proposed an MDGender evaluation data set. They collected it through two steps. They first collect conversations between people. I think people who cloud workers. So they're given prompts in the form of personas and biographical information, and they're asked to have a conversation. And then these conversations are taken down, and annotators rewrite each sentence to make clear that there is about, to, or as gender information present in every single sentence. So, for instance, say we have a sentence, "How are you, Lakadit?" You would to make it clear that it is speaking to a man, you would maybe rewrite it as, "How are you, Mr. Lakadit?" And yeah, so and this is the accuracy on the evaluation data set for the different classifiers. So the for the average of all the dimensions, the multitask classifiers performs the best. So they wanted to look at the effect of removing some gendered words from the data set when training. So I guess for Wikipedia only, you have this accuracy. And then they removed all gendered words based on some word list, and they got a lower accuracy. And then they removed gendered words and names from their data set. And then they still it's a lower performance, but it still performs pretty well. So that I guess kind of shows that even non-explicitly gendered words can carry some gender information. So let's talk about utility and downstream applications. So they want to do some controllable generation of text. So what I understand is that they took 250,000 comments from Reddit that was actually prepared from someone else. It's an open data set. And they labeled it using the multi-task classifier. And they used that to train some model, which sequence-to-sequence model, which takes an input of text and then and produces some other text. So like, let's say if the input is, oh, cute, ours are a handful, but they're like babies, 4 wiener dogs. So and then they'll generate some other text based on their input, based on the different dimensions. So and the baseline they use is a word list. So basically, rather than using the multitask classifier to label the sentences, the input, they use a word list. So basically, if the input has more female words than male words, they label it female. And if the input has more male words than feminine words, rather, then they label it as a masculine input. So so the statistics that come out. Oh yeah, and so basically at the end of the things, after the training, they use the control token to control kind of what's generated at the end. So if for the two feminine, so this is the percentage of gendered words in the output that is masculine. So you can see that for the feminine stuff, it's lower, a lower percentage of masculine words, and for the masculine control token, you get output that has a higher percentage of masculine gendered words. And so this is some of the sample input and output. So bias detection. So so I don't really know what the authors were doing here, but they were kind of they basically showed us some distribution of gendered scores on male and female biographies, so that they found that all biographies are kind of skewing towards the masculine side. Yeah, so and yeah, I don't really understand why they do this, but sorry. And offensive content. So the authors took some offensive content and took a look at the genderedness of the offensive content. So when they look at they look at the offensive content, and they look at what percentage of the safe content and what percentage of offensive content is masculine gendered text. So for the about dimension, you see that safe content is for the safe content, 81% is masculine, but for the offensive content, only 70% is masculine. So I guess like the conclusion here is that for when you're talking about someone, it's relatively more common to have offensive comments about women than men. Right. And then as to the to and as dimensions, so when you're talking to a man or you're talking as a man, the safe percentage for men is much lower. Yeah, and there is a relatively more offensive content when you're talking to a man or as a man. So yeah, so that's all. Thank you.